In March 2010, a team of researchers traveled from Rice University in Houston to Guanajuato, Mexico. They were from Rice's Center for Biological and Environmental Nanotechnology, or CBEN. Funded by the National Science Foundation, CBEN is dedicated to developing sustainable nanotechnologies that improve human health and the environment.
Nanotechnology is one of the most exciting frontiers of technology that we have right now, because it's a technology that's grown explosively in our scientific understanding, and we're really fortunate now to see the very first steps, not baby steps, maybe bigger steps, into the real world as all of those new tools and concepts become applied. So it's an incredibly important and exciting place to be, and it comes at a time that the world is going through enormous change in how it thinks about countries, about the problems it faces. And so nanotech is really going to be at the heart of what the 21st century is going to be about, which is improving the quality of life for all of the world's citizens.
In Guanajuato, the CBEN team was testing nanorust, a new material they'd discovered 4 years earlier. Rust has long been known to chemically leach arsenic from water. By shrinking the size of the rust particles, CBEN researchers can create filters that soak up arsenic like a sponge.
We in Guanajuato have a problem with arsenic. We're very happy here in Guanajuato. Our land is very rich in minerals. That's why Guanajuato is one of the main places for silver production in the world. The Spanish came here, they found a lot of minerals, they found a lot of silver, but also there is a lot of arsenic.
Ultimately, the goal is to treat well water as it's pumped from the ground in the Mexican countryside. It's a tough engineering problem because the chemistry of each well is slightly different. On this trip, Rice graduate student Jesse Farrell and CBEN research scientist John Fortner built 3 filters. Packed with gravel, sand, and nanorust, the filters provided crucial data that could help make nanorust treatment a reality in Guanajuato.
Well, in this column that we just set up here at the well site, we're getting water directly from the well behind us, and the water is laced with arsenic, and as it goes through the top, it enters our column and then comes in contact with a nanomaterial layer that we have in the center of our column here.
Right. So the black layer you see here is a layer of nanomagnetite. It's been a little bit diluted with sand, but as the water pouring through it, as the water pours through the column, trickles through the column, it comes in contact with the magnetite, and out comes the arsenic, and out comes clean water.
The CBEN team also conducted tests on 2 other nanoparticles that could be useful in cleaning water at Guanajuato's sewage treatment plant. These tests and those on nanorust are some of the first to move nanotechnology beyond the laboratory and into the real world. The challenges are great, but the results could help ensure the safety of drinking water, not only in Guanajuato, but in communities across the globe.
We expect in every new well we make, we're going to have high arsenic concentrations. And that's why we think we're just on time of working in a solution. Of course, there are solutions right now with the available technology, but they're too expensive for us because many cities in Mexico and also in other countries around the world, they have very important problems with arsenic in their water. I know nanotechnology will be the technology